Hello everyone and welcome to today's NECTO Studio webinar. My name is Branko and I will be guiding you through designing a smart home interface, just like this one over here. And I will be doing that by using NECTO Studio and the Mikromedia hardware platform. Over the next 30 minutes, we will explore how to build a graphical interface by connecting real hardware like relays, sensors, and stepper motors, just like this one over here. In this session, we will cover setting up a NECTO Studio project for graphical development. Then we will explore the Mikromedia platform and LVGL building blocks. Then we are going to create interactive controls for lights. Something like this. See, it actually works. Okay, perfect. And of course, we are definitely going to create interactive controls for heating. And if I click or if I slide over here, you will be hearing a relay clicking. See? Okay, perfect. And of course, we are going to create interactive controls for windows. If I perform slide clockwise, the stepper motor is definitely going to move clockwise. If I perform the counterclockwise movement, the stepper motor will run counterclockwise, just like this one over here. Okay. By the end, you will understand how to combine visual design with hardware, just like this one, to rapidly build and test smart home interfaces. Now, let me explain. Let's take a closer look at the Mikromedia board and the LVGL graphics library. The Mikromedia boards are all-in-one development systems that include a TFT touch, just like this one, okay, microcontroller, and the microbus slots for clickboards, just like over here. Today, we are using the Mikromedia 5 for STM32F7 capacitive, which provides a high-resolution capacitive touch interface. Let's talk briefly about LVGL, the open source graphics library we are currently using. LVGL is designed for embedded systems with constrained resources, yet it provides rich widgets, just like those over here. It provides animations and it, of course, provides touch support. In NECTO Studio, LVGL is already included into the MikroSDK framework, meaning you can immediately start designing buttons, sliders, arcs, labels, and more. And we have two important concepts to know for today. Widgets, these are visual elements, like buttons, switches, labels, and arcs. Each widget can be linked to your application logic. That is number one. Number two, event-driven callbacks. LVGL allows you to attach C functions to user interactions, such as touching a button or rotating an arc, just like this one over here. Okay, next we will jump into creating a graphical project in NECTO Studio, where we will start bringing those concepts to life on our Mikromedia board. Now it is time to start building our GUI application using NECTO Studio. Step 1 would be open NECTO Studio and launch the new project wizard. Then name the project Smart Home Automation and select a destination folder. Then select a complex designer project as the type, which is going to enable LVGL design tools and smart display integration. Pick the Mikromedia 5 for STM32F7 capacitive hardware profile. This ensures the IDE generates the correct initialization code for our current display and peripherals. Once the project is created, NECTO opens the GUI-Centric workspace. This is where all automatically generated files appear, including the essential hardware initialization for your Mikromedia board. Let's take a look at the main.c file, which forms the backbone of every LVGL-based project. At the top of the file, you will notice a few important includes: pre-init and delays. Those handle low-level MCU setup and delay functions needed for timing. Next up is the display LVGL and LV port input device header files. Those two take care of LVGL's connection to your hardware display and of course input devices such as the touch screen. And finally, we have the screens header file. This file ties all the visual screens together. It is automatically managed by NECTO's designer, so you can easily switch between graphical user interface layouts later in the later stages. The file defines two key intentional functions, board init and application init. In terms of the board init, this is where the LVGL core is brought to life. It initializes the display driver, the input driver, and it configures a 1 millisecond timer interrupt that LVGL uses to track time internally. Without this, animations, screen refreshes, and input events would not work correctly. And finally, application init. This is the entry point for your project's logic. It first calls board init to bring up the system, then it calls init screens to prepare all user interface screens, and finally, show main screen to display the default one. So from this point on, your graphical interface is active and ready for user interaction. Finally, the main function is a simple infinite loop, which continuously calls LVTask handler and of course delays. This is the heart of every LVGL application. It keeps your graphical user interface responsive by processing drawing updates, animations, and user inputs in real time. At the end of the file, there is also an interrupt routine that runs every millisecond. It feeds time updates to LVGL through LVTick function and processes touch inputs events. In simpler terms, this ensures your graphical interface runs smoothly, it tracks time accurately, and it responds instantly to user touches. So before adding any graphical user interface logic or clipboard integration, this is the foundation that keeps your smart home interface alive, and it runs on the Mikromedia display. Okay, now click the Design button in the left sidebar. Here you can see the preview of your TFT screen. The right panel provides all LVGL components such as buttons, switches, arcs, labels, and text areas. Then drag a text area to serve as a headline for the interface. Label it Control Your Home with Mikromedia. Finally, drag an image object and place a small house icon on the left side of the screen for visual context. Navigate to the Build and Flash in NECTO Studio, and ensure the Mikromedia 5 for STM32F7 board is connected via USB to the code reprogrammer debugger. Click Flash to upload the firmware to the board, and now, finally, we have the initial screen, a clean interface with our headline and house image. Now let's implement our first functionality, Control Lights. Drag a label called Control Lights. Now drag a switch object and assign it to control Relay 1 on this Relay 3 clipboard. By making sure Relay 3 clipboard software package is already installed inside the NECTO's package manager. And yes, here it is installed. Let's enable this clipboard inside our project by navigating to the library manager and search for this particular clipboard. Okay, now let's enable it. Finally, we can include necessary header file for it, necessary initialization code for this Relay 3 clipboard as well, to be able to properly run this one on our Mikromedia board. Finally, event callback code. I will just copy the pre-written event callback code into main screen.c file, and I will flash the project to the board. Now, I'm currently demonstrating turning the lights on and off by the physical switch on the Mikromedia display. Focus on the control light section. If I toggle the first switch on the screen, the first relay activates. The lights are going to be turning on. If I perform the toggle, relay deactivates and the lights are going off. Next, let's implement our second functionality, control heating. Once again, drag another label called control heating. Drag a second switch and assign it to the another relay switch on the Relay 3 clipboard. I'm just going to copy paste the event handler code, and I will flash this version of the project. If I slide the switch, the relay is going to toggle itself. which is what we need to be able to control, for example, heating. Finally, let's control windows via stepper motor. Drag a label named control windows. Drag an arc widget and position it as a semicircle. I'm just going to copy paste this motor control logic into main screen source file, and I will demonstrate the real-time movement. If I rotate the arc to the left, it will move the stepper 25 click motor counterclockwise. And if I rotate the arc to the right, it will move the stepper motor clockwise. And there you go, guys. As simple as it can be. Now I'm going to show temperature and humidity updates. I have inserted necessary labels, and they're going to be updating live based on the sensor readings. I have inserted 4 labels to be precise. And of course, here is the code for temperature and humidity acquisition, which I basically copy-pasted. If I flash this code, now we have the fully functional home automation graphical user interface application, powered by NECTO, clipboards, LVGL graphics framework, integrated into MikroSDK, and of course, Mikromedia devices. Okay, before we dive into the code in more details, let's take a look at the hardware setup. This project combines 3 clipboards. Relay 3 clipboard, something like this. Just give me a second. And here it is. Relay 3 clipboard. Okay? And this Relay 3 clipboard controls 2 relays. As you can see, number 1 relay and the number 2 relay. Okay, the next clipboard that we are actually using is temperature and humidity 24 clipboard. This guy over here. This one measures ambient temperature and humidity. And the last clipboard is the stepper 25 clipboard, which controls the bipolar stepper motor through SPI interface. Each of these clipboards needs to be installed through the package manager in NECTO Studio. So make sure to open the package manager, this feature over here, and make sure to search for those clipboards and then install their libraries inside the library manager. So for example, Relay 3 clipboard over here, and make sure that this item is checked. So this library has to be checked. Okay, now let's move on to the main function, this main.c file. This file over here. Okay, each clipboard instance is declared globally, and you can see it over here. So once again, stepper 25, temperature and humidity 24, and relay 3 clipboard, along with the logger, which gives us real-time feedback through the USB UART console. Okay, then we are going to go to the application init, this functionality over here. Here all drivers or peripherals are brought to life. The logger is configured for the USB UART communication. Here is the logger, and it is configured for the USB UART communication. And each clipboard is initialized on its corresponding microbus sockets. So for example, Relay 3 clipboard is configured for the microbus 1 slot. Temperature and humidity 24 clipboard is configured for the microbus 2 slot. And the last one, the stepper 25 clipboard, is configured to be placed on the microbus 3 slot. Okay, then we are going to go to the application init, and here it is, application init. Okay, and basically that's it. We are just going to call this functionality inside the main function. Then for the last time, we are going to focus on the main functionality, the while one loop, this one over here. It continuously runs LVGL's LV task handler and calls update temperature and humidity functionality to keep the on-screen data fresh. Okay, now that our system and clicks are initialized, let's see how the screen logic is implemented. So we basically have to transfer ourselves to the main screen functionality over here. Okay, first of all, let's focus on the relay control. Relay control, relay switch handlers. Okay, first two switches, there are two switches, switch 0 event handler and switch 1 event handler. And they both control the relay tree outputs. What does it mean? Well, when toggled, they turn the relays on or off, something like this. So we are going to use relay 3 relay on and relay 3 relay off. And that is basically the same for the switch 1 over here. So relay 3 relay on and relay 3 relay off. And what does it mean? If you jump into the design over here, this means basically control lights, and that's basically it. This functionality over here. Okay, let's get back to the code section once again. Okay, and the next feature that we have to focus on is the temperature and humidity update. Here it is. Here is the functionality which basically gets us the temperature in Celsius and humidity over here. Okay, and it also logs historical minimum and maximum readings to the console. Okay, that was it for the temperature and humidity. Now the last thing that we have to focus on is the stepper control via the arc widget. So let's visualize it. Jump into the design over here, and here it is. We are going to control windows, or basically we are going to control the stepper motor by utilizing the arc built-in component, which I basically utilized from the option over here. Okay, focus on the code once again, and yeah, rotating it clockwise, rotating this arc clockwise, it will basically spin the stepper motor clockwise logically. And in other case, if we rotate the arc counterclockwise, it will basically control the stepper motor in the counterclockwise action. Okay, and these modules all together demonstrate a complete embedded UI system. So we've got the visual feedback, we've got the user input, we've got the real-time actuation, and it is all built within the NECTO Studio using the LVGL designer and clipboards. Okay, and now I'm going to transfer to myself right now. Just give me a second. Okay, perfect. Okay guys, question and answering session right now. And I think that we already have one question or two questions, which is nice. Yeah, the Oliver asked, can the same project be easily migrated to another dev board, for example, to bigger Mikromedia? Excellent question, and I'm going to answer it right now. Yes, absolutely yes. So NECTO Studio is fully integrated with the Planet Debug environment. Yeah, you can definitely use it on the Planet Debug, and you can basically use some other Mikromedia development board. So since the project is built using the MikroSDK version 2.0, it is fully portable across all boards. So you do not have to use this board over here. You can use the larger one, the smaller one. And yeah, I think that I answered your question right now. Okay, and the question number 2 would be, what is the advantage of combining LVGL with NECTO's code generation? Good question, compared to writing everything manually. Yeah, using LVGL Designer inside NECTO Studio, it basically drastically reduces development time. It allows engineers to visually design interfaces, while NECTO automatically generates clean, structured C code that's immediately ready for integration with the hardware drivers. Okay, I think that I answered your question as well. So, guys, ask anything that you want, and I'm just going to talk about this subject even more. Okay, while we are waiting for some of your questions to come in, let's take a moment to reflect on what we have built today and why it matters. What you have seen is not just a simple demo. It was a full functional prototype that shows how easy it is to combine hardware, software, and user interface by utilizing the NECTO Studio, and it actually looked awesome. So we started from a blank LVGL designer project. We have added our clipboards. So once again, relay 3 clipboard, temperature and humidity 24 clipboard, and stepper 25 clipboard. And we integrated them into the working user interface application. And everything was configured directly within the NECTO Studio, without the need for any external tools or manual wiring in the code. Okay, so yeah, this is exactly what makes NECTO Studio special, the way it connects designers, firmware engineers, and hardware developers in a single workflow. You can visually design your interface, automatically generate code, you can integrate clipboards through the package manager, and I have the entire logic running on the real hardware within minutes. And another thing worth mentioning is how modular this approach is. For example, if we wanted to replace the stepper 25 clipboard, so this guy over here, if we wanted it to replace with the DC motor, for example, or change the temperature and humidity 24 clipboard with another sensor, the process would remain exactly the same. You just change the clipboard, you just include its library and map it to a microbus socket. The rest of the logic stays untouched. That is the power of the standardization through the microbus and clipboards. And this really represents the spirit of rapid prototyping. Okay, I'm just going to catch up with the questions if we have some more questions. Not yet. Okay. Not yet. Okay. I'm just going to continue. So guys, please do ask anything that you want in terms of this subject. And by the way, you can ask anything about the NECTO Studio as well. Okay, whether you are working on an industrial prototype, a smart home system, or an educated showcase, NECTO Studio and clipboards give you a head start. And I also want to highlight the integration with Planet Debug. I haven't showed the Planet Debug right now for this current webinar session, but our remote RT lab, which can basically allow developers around the world to test, debug, and deploy firmware on real hardware directly from their browser, directly from their NECTO Studio. You can combine that with the NECTO ecosystem and you have a fully remote embedded development workflow. And if you think about it, what we are seeing today, a user interface controlling relays, it displays live sensor data and it manages a stepper motor, this one over here. We can easily scale into a much larger system. Just imagine replacing the relay outputs with a power stage. You can add environmental sensors and maybe connecting through Wi-Fi or LoRa, because we already have some Wi-Fi clipboards and we have already some LoRa clipboards as well. So the same software foundation stays in place. You just keep building on top of it. Okay, let me just check for some questions. Not yet. Okay, there are no more questions right now. Okay, I'm just going to continue talking. So guys, ask anything that you want. Okay, all of those things that I already just described, this is exactly where NECTO is headed. It is headed toward helping engineers think less about the hardware setup, think less about the Mikromedia device, think less about the clickboards, and think less about the peripherals, and think more about the actual creation of the project. So the IDE takes care of the boilerplate, the peripheral mapping, and the low-level details, leaving you with the more time to focus on innovation. Okay? One more practical tip for everyone following along: always use the application output window. I'm just going to show it to you. Okay? Always use this application output window and the compile output as well, and the issues windows. And why should you use that? Well, it is not just for the debugging. It is just for for live insight into what the system is actually doing. Whether you are monitoring sensor readings, state changes, or communication errors, that console feedback can save you a lot of time. And by the way, it helped me a lot while I was developing this exact project for this exact webinar. And it will definitely help you validate your design on the spot. Also, remember that the LVGL designer isn't only about visuals, it is about logic control as well. You can bind events, callbacks, and data updates right into the widgets, and you can actually create a link between user interface, your user interface, and the physical world, just as I basically have done it with the stepper motor and the home house light. Okay, are there more questions? Not yet. Okay, not yet. Okay, so while we still wait for a few more questions, I would like everyone watching to think about how this approach can fit into your projects. And what would you build if you could integrate sensors, actuators, and a touch display in under 1 hour? Okay, let me check about the questions. Nothing yet. So guys, please do ask anything that you want. Okay, I would also want to thank everyone who joined today's session and took the time to follow the entire process from idea to implementation. Our goal is to make each webinar not only a demonstration but also an inspiration for what you can create next. So if you have any feedback, if you have any suggestions or ideas for future webinars, feel free to share them right now, or you can send me a message, etc. etc. Okay, we are always happy to hear what would make your workflow faster and your projects more enjoyable to develop. So I'm just going to catch up with you guys once again, and I'm just going to check whether there are more questions for me right now. And yeah, if there are no more questions for me right now, I'm just going to wrap up this webinar session. I will definitely say thank you once again for being here, and I hope this session gives you new ideas and confidence to build your next smart application using NECTO Studio. And by the way, using NECTO Studio, using NECTO Designer and clipboards. Okay, I think that is it, guys. So if you have something to ask, please do ask right now. I'm just going to wait for a bit. while we are waiting, I'm going to provide you with a hyperlink from which you can basically jump into all of those webinar sessions that I have done, that I have hosted in terms of the NECTO Studio projects, etc, etc. Okay, I'm just going to wait for a bit even more. Okay, I think that's it, guys. So thank you once again. Thank you for watching this webinar session. And yeah, I will definitely say goodbye to you guys. So see ya. Thank you.